Welcome to this class. In this session, we are going to briefly see how we can apply both the power rule and product or quotient rule to a given problem and get the same result. So calculate the derivatives in two ways. First, by use of product or quotient rule. Then derive the function algebraically and apply the power rule directly. So the first function, a f of t is given by 2t plus 1 t squared minus 2. So the structure of this function allows us now, the first method is to use product rule. So solution or method 1, product rule. So let u to be 2t plus 1 and v to be t squared minus 2. So this means that u prime is 2, and this means v prime is 2t. Now, f prime of t is the same as u prime v plus v prime u, which is 2 into t squared minus 2 plus 2t into 2t plus 1. So f prime of t will be 2t squared minus 4 plus 4t squared plus 2t. Now, this, when you collect like terms, f prime of t, 2 plus 4 is 6, then plus 2t, and then minus 4. So the answer will be 6t squared plus 2t minus 4. That's method 1 by using product rule. Now method 2, power rule. So to apply power rule, we will be forced to simplify or to open the brackets 2t plus 1 and then t squared minus 2. So 2t by t squared is 2t power 3, 2t by minus 2 minus 4t plus t squared minus 2. So f of t is 2t cubed plus t squared minus 4t minus 2. So which implies by power rule, f prime of t, you drop, so we'll have 2 by 3 is 6, t squared plus this will be 2t, and then minus 4. The derivative of a constant is a constant, so this will be the answer, which is the same as the answer when you use product rule. A b, the function is f of x is equals to x squared into 3 plus x raised to power negative 1. So method 1 will be by product rule. Product rule. So product rule, we let u to be x squared and b 3 plus x raised to power minus 1. So this means u prime is 2x, This means v prime is minus x raised to minus 2. So by definition, the derivative is u prime v minus v prime u, which will be 2x into 3 plus x raised to minus 1, this plus not minus, plus minus x minus 2 into u x squared. And this implies that the derivative of this function, 6x plus 2 minus 1 plus 1 is 0, and then minus this also be 1. So 2 minus 1 is just plus 1. So that's method 1 by product rule. Method 2, power rule. So power rule dictates that the first thing we have to open brackets. So f of x was given by x squared into 3 plus x raised to minus 1. So this is 3x squared minus 1 plus 2 is 1. So x. So f of x is 3x squared plus 1 plus x. So which means by power rule, f prime of x, drop the power, so I have 6x, and then the derivative of x is 1. So which is the same, 6x plus 1. C, we have h of t given by t squared minus 1 divided by t minus 1. Method 1 would be by quotient rule. Quotient rule. So we let u to be t squared minus 1 and v to be the denominator t minus 1. So this means u prime is 2t, v prime is 1. So h prime of t is u prime v plus v prime u, which will be 2t times t minus 1 plus 1 into t squared minus 1. Okay, so sorry, that is this not quotient. So quotient rule states that. So this will be u prime v minus v prime u divided by v squared. So which will be 2t into t minus 1 minus 1 into t squared minus 1 divided by t minus 1 squared. So this numerator, you see, can be written as 2t without opening. This one, t squared minus 1, is a difference of 2 squares. So it can be written as t minus 1 times another t plus 1. Those are difference of 2 squares divided by t minus 1 squared. Then this term and this term, t minus 1, is common. So you'd say h prime of t is equals to t minus 1 into 2t minus t plus 1 divided by t minus 1. Now square is the same as t minus 1 times t minus 1. Now by doing that, I cross 1 with this other one here, so that I have h prime of t is 2t now minus t minus 1 divided by t minus 1. And 2t minus t is t minus 1 over t minus 1. And you see t minus 1 gives us so this is 1. So therefore, h prime of t is 1. That is by quotient rule. Method 2, we need to use power rule. Power rule requires that we need to simplify the algebraic expression given. So method 2, power rule. Now, the question is h of t is t squared minus 1 over t minus 1. You see, this is the same as t minus 1, t plus 1. This is a difference of two squares, and then t minus 1. And then by writing this as factor of those two, then we just have t plus 1. So i.e., the function h of t is just the same as t plus 1. And you see, by power rule, h prime of t is just 1 because derivative of constant is 0. And lastly, d, we have g of x is given by x power 3 plus 2x squared plus 3x minus 1 divided by x. So first method is to use quotient rule. So we let u to be x cubed plus 2x squared plus 3x minus 1 and v to be x. So this tells us that u prime will be 3x squared plus 4x minus 3x minus 2 and v prime is 1. So g prime of x by quotient rule is u prime v minus v prime u over v squared, which will be 3x squared plus 4x minus 3x minus 2 times v, which is x, minus v, which is 1, times u is x cubed plus 2x squared plus 3x minus 1, and you divide by v squared, which is just x squared. Now g prime of x will be 3x power 3 plus 4x squared minus 3x power minus 1 minus x power 3 minus 2x power 2 minus 3x minus 1 divided by x squared. So this will be 2x power 3 and then plus 2x power 2, then minus 6x power minus 1 divided by x squared. And you see this is the same as we divide each term by x squared, so 2x power 3 over x squared plus 2x squared over x squared minus 6x minus 1 x power 2. And on simplification, we'll get 2x plus 2 minus 6x power 3. So this is the derivative. Now, method 2, power rule. Power rule will require us to simplify that given function. So g of x was given by x power 3 plus 2x squared plus 3x minus 1 divided by x. So this is the same as g of x equals to x cubed over x plus 2x squared over x plus 3x minus 1 over x, which is the same as x squared plus 2x and then plus 3x minus 2, just using loss of indices. So I have g function is x squared plus 2x plus 3x raised power minus 2. So by power rule, should be easy to be seen that this would be 2x plus 2 and then minus 6x minus 3, which is the same thing as saying 2x plus 2 minus 6 over x power 3. So that's how we solve that problem. Thank you.